Hi, Professor. I am Myanmar, and today I would like to present to you about the Kage project, Zero Bright Zero Hole Value Prediction Estimate. Here's the table of content. Problem statement. The project is to develop the machine learning model that can predict the error of the estimate for individual property. The objective is to reduce the mean square error between the estimate and the actual sale price of a property. The dataset includes the number of patrons, square footage, location, and time series data on the property sales, etc. The challenge is to use the property to develop the prediction model that can accurately estimate the error of the estimate for each property. Prediction model. Here we use three prediction models: linear regression, XGBoost, and LightGPN. Linear regression is the statistical and machine learning technique for modeling the connection between a dependent variable and one or more independent variables. XGBoost is a machine learning technique which combines weak prediction model to get a final model that is stronger and more accurate. It functions by incrementally increasing the model accuracy by adding the decision tree. LightGPN is also a machine learning algorithm that creates the trained models by merging with prediction models such as decision trees. Using the leaf-wide tree development strategy is intended to be quicker and more memory efficient than the existing gradient boosting algorithms. Methodology. We first preprocess the data, then we split data into trained models, then we evaluate the result and compare the result to get the best one. The first step was to preprocess the data is to prepare it for training the models. This includes removing missing and null values. Removing missing values is important as missing value can cause error in the training process. Data cleaning is one of the important aspects in designing the prediction model. No matter how good the model is, without properly cleaned data, it cannot perform up to its potential. The preprocessing technique used are as follows. We create a send new column to collect linear dataset. We draw some columns as they are redundant or unnecessary for the model, and some values are filled as they see fit. After we process the data, we use a split dataset provided to train the model. This is a common practice in machine learning to prevent overfitting, where the model becomes too closely fitted to the training data and perform poorly on new data. We trained three different models on the training set. The first model was linear regression, with a simple linear model that assumed a linear relationship between input feature and the target variable. The second and third model were XGBoost and LightGPN, which are complex nonlinear models based on gradient boosting. For XGBoost and LightGPN, we tuned the hyperparameter using the random search over predefined range. We evaluated the performance of each model on the validation set. We used the mean absolute error, MAE, mean square error, MSE, and R-square as performance metrics. MAE and RSE are measures of the difference between the predicted and actual values, with lower value indicating a better performance. R-square is measure of how well the model fit the data, with higher value indicating a better fit. Okay. And we compare the performance of the three models based on their MAE, RMSE, and R-square values. We found that the complex non-linear models XGBoost and LightGPN perform better than the simple linear model, linear regression. LightGPN achieved a slightly better performance than XGBoost, possibly due to the faster training time and ability to explore a larger space. Here are the result comparison. As can be seen from the table, all three models perform similarity in terms of the score generated from Kaggle. However, LightGPN model achieved a higher rank, indicating a better fit to use for its dataset. Here's the evaluation score and ranking position on Kaggles. That's a roles and contribution. Challenge phase. The provided dataset contains a large number of missing values and redundant columns, which require more difficult pre-processing to get useful value. Moreover, doing research to find out most relevant machine learning models to predict the log error was another challenge. Based on research, XGBoost and LightGPN are stronger prediction models, yet they may need cleaner pre-processing data. Due to manpower constraint, we were unable to conduct further research to apply deeper pre-processing technique in the project. Conclusion: in this project, we learned that the data cleaning is an important step before applying machine learning models. Additionally, the choice of the model depends on the dataset and the types of problem. Linear regression is a good choice for continuous numerical data, and it gives the linear relationship between the dependent and independent variables. Although XGBoost and LightGPN are better suited for this project, LightGPN has a higher score as it's designed to be higher scalable, efficient when used for the larger dataset with many properties and faster training time. Lastly, comparing different models and experimenting with them is necessary to choose the best model for the given problem. Thank you for the time.